we're going to take a step back from the quadratic algebra we've been doing and actually start to look at the graphs of quadratic functions. Okay, so today we're going to start with this thing called a transformations investigation. Okay, and the first thing we're going to look at, this is part one, is what we call a dilation from the x-axis. But it's really important that beginning with this graph here, y equals x squared, we're going to call that the most basic parabola, y equals x squared. And it's a bit like the linear function y equals x. So that's the linear function. It's the most basic linear function. Is just for every value of x you choose, y is the same value. And it produces this graph over here. So let's investigate what the basic y equals x squared graph looks like. So we're going to first of all complete the table of values. Okay, so for it. Now let's use the calculator to help us out with the table of values. So we're going to go to Menu, Graph and Table, and let's just dump any previous graphs that we've got there and go y equals x squared. Let's check out the graph. Go check it to check out the graph. All right, there it is. Okay, so now what we can actually get the calculator to do is produce the table of values for us. Now we could do this quite easily ourselves, and I'm going to do that ourselves first of all, but we'll show you, or I'll show you how to do it on the calc as well. So when I sub x is equal to 0 into the relationship, we get 0 squared, which is 0. So there's a coordinate point 0, 0 on there. That's there. Right, when I sub 1 in, I get 1 squared. 1 times 1 is 1. When I sub 2 in, I get 2 squared, which is 4. And when I sub 3 in, I get 9. Now over here with the negative values, when I sub negative 1 in, negative 1 times negative 1 is positive 1. Negative 2 times negative 2 is positive 4. And negative 3 times negative 3 is positive 9. And again, what you can maybe see is you get this symmetrical sort of, these values here are symmetrical. Okay, and that's what gives the parabola its shape. Right, so we've got 1 and 1. Gee, the scale's not that great on this. 1 and 1. We've got negative 2 and 4. So there is negative 2 and 4. Negative 2 and 4. And negative 3, 9. Where's 9? It's about there. There. All right, now I'm going to have a little bit of difficulty drawing this. Again, I've made the excuse before, but I'm not drawing on the screen itself, but on a pad sitting in front of my computer here. So it's a little bit difficult to do. Here's my best effort. Not too bad. Okay, now again, let's look at problems with this. Should go to the point, should go through the point, can't go below the y-axis. Okay, it should go to that point there. And the graph should look symmetrical about this midpoint here, because whenever you square these positive values here, the negative values when squared will be the same value as well. So it gives the parabola its unique shape. All right, so let's then ask it to do the table of values for us. So what you can do is, I'll just go back to what I just pressed there. So I'm going to go X on that and hit this button here. It's the table of values. Okay. Now what you can do is change the settings for that. So I'm going to actually change not those ones. Is it those ones? Yes, it is. So table input. So what we're going to do is get it to start at -3, end at +3, and have a step value of 1. That means it basically is going to generate values going up by 1 from -3 to +3 inclusive. And there's my table, and you can see there the values that I've got. Okay, so now what we want to do is complete the table of values to plot the points on the grid above. So we're going to plot these graphs one after another. So this one here is y equals 2x squared. So notice here that what we're doing is we're going to vary this value here, the coefficient. Okay, so that's varying what we call the a value. It can be the b value or the c value. It doesn't matter about the letter, but it's the coefficient to the squared term that we're going to have a bit of a play around with. All right, so what I'll do is I'll just update my graph. So let's get rid of that. We'll check out the graph, and all I'm going to do is change it to a 2, regraph it, and regenerate my table of values. Now you can sub that in by hand, or let's just do this. 18, 8, 2, 0, 2, 8, and what I presume will be 18. All right, let's plot those points. So we've got 0, 0, negative 1, 2, which is there, 1, 2, which is there, 2, 8, and negative 2, 8, there, there, and 18, all the way up there, and there. Okay, so you see what happens with this A value here being 2. What it will do, let's see if I can draw this parabola. It's a pretty good effort, that. I'm happy with that one. Again, a bit jittery here. Your curve needs to be nice and smooth, okay? And it needs to be curvy. You can't draw straight lines connecting that. It's got to be a curvy curve, so to speak. And what you'll notice is that if you have a look at each of the Y values here, okay, they've doubled, okay? And so what we're actually doing here, this is called a dilation from the x-axis by a factor of 2, okay? And to dilate from the x-axis, I want you to note that the x values stay exactly the same. What changes is the y values, okay? So when we want to dilate from the x-axis, we change the y values. That's a very important thing to note. All right, this one here, maybe you can predict what's going to happen here. This is a value of a half. And what I anticipate, girls, is that each of these y values here, instead of doubling, in this case here, are going to halve, okay? Right, let's try it out. So I'm going to kill the table of values, change my function, 0.5, regraph it, and ask it to generate the table again. And sure enough, 4.5, 2, 0.5, 0, and I can't see it, but I know it's going to be symmetrical, etc., etc. All right, so you're going to plot those points, and what we'll note, we've got 0, 0, negative 1, 0.5, that's going to be really tough to plot, somewhere down here. Okay, and we've got negative 2, 2, which is here, and negative 3, 4.5, so there's 4 somewhere here. And down here, just make sure it's symmetrical. There. Right, best attempt. There, all right, let's make sure we're labeling this. Y equals 0.5 x squared. This one was y equals x squared, and this was y equals 2x squared. All right, now the final one, can you anticipate what the negative will do? Okay, well, I know that it will actually negate all of these squared values here. So this will be negative 9, this will be negative 4, this will be negative 1, 0, negative 1, negative 4, negative 9. Try it yourself and see. Now you'll also note that what that will do, see if you can anticipate what that will do to the parabola first of all, but I'm going to go ahead and graph the thing as well. I'm going to change that to a negative, and oopsie, get rid of that multiply. Oh, goodness me. All right, so what it does is it inverts the parabola or reflects the parabola in the x-axis. Okay, so let's sketch that one up. We've got 0, we've got negative 1, that's there, negative 2, negative 4, negative 3, negative 9, down there, and it's symmetrical, so all right, let's see if I can do an inverted one. Yep. There we go there. Now again, you're not allowed to make shape corrections on that. You've got to rub that out and make sure it's just one clean curve. Y equals negative x squared. So what effect does changing the A value have on the shape of the parabola? Okay, so two things. What it will do is dilate from the x-axis and possibly reflect if negative. Okay, so if it's a negative sign, what we'll do is we'll reflect if negative in the x axis. So it's important to note that it's going to be a reflection in the x-axis because later on we'll start reflecting in the y-axis as well, and we've got to make sure that we state which one it will be. Right, how have the coordinate points changed compared to y equals x squared? Okay, x values same, y values change by a factor of a. So whatever the a value is, it changes by that factor. All right, so that's what we call dilations. All right, so on to the next type of transformation. And what we can do is do what's called a vertical translation. That is, grab the parabola and move it up or down. And this k value here is the thing that does it for us. Okay, so we've got the y equals x squared already graphed. Okay, and what we're going to do is think about what this will do. So y equals x squared plus 2, what this will do is actually add 2 to all the y values over here. So we're going to square them, and that would be what the numbers come out, and then stick 2 on top of each of those. So this one's going to be 11, this was going to be 6, this one's 3, this one's 2, this one is 3, 6, 11. Let's check it out and see whether I was right. Plus 2, graph it, table please. Yep, okay. So let's plot that one. So basically it'll be the same shape except all of the values have moved up 2 units. So that'll be there, that'll be there, that'll be there, and oh, hang on, no, this is a different scale. Okay. All right, so this is 0, 0, which will go to 1, 2. That's going to go to 2, 0, 2. Okay, then there, there, there. Right, so the left side of the parabola will look like that. Let's go another 2 unit translation. There, there, there. Okay, so again, what we'll do is we'll get the same shape, but all of the values will be just 2 units higher than the previous. Okay, see if you can anticipate what will happen here. This will be all of these squared values here, except we're going to remove 3 from it. So we're going to get 6, 1, negative, removing 3, negative 2, negative 3, negative 2, 1, 6. Right, let's plot those. So we've got 0, negative 3, negative 1, negative 2, 2, 1, and negative 3, 6. All right, round we go. All right, so again, can you please make sure that you cross your T's and dot your I's, make sure it goes through all of the points, it's a nice smooth curve. Okay, again, good practice to label your graphs when there's multiple functions on the page. Y equals x squared, y equals x squared plus 2. What effect does changing the k value have of the position of the parabola? It translates the y equals x squared graph k units up or down, depending on the value of k. How have the coordinate points changed compared to y equals x squared? Well, so x values same, y values go up or down by k. All right, k units up or k units down. All right, this one here is the counterintuitive one, and it's going to take a little bit of practice to get used to what we're about to do. Okay, so we've got a horizontal translation. Okay, so complete the table of values for each of the following. We've got the y equals x squared drawn here, and what we want to do is graph this one here, which is y equals x take 2 all squared. Now, what a lot of you will intuitively think is this K value here moved it up or down K units. And if it was +2, it went up 2. If it was down 3, it'd be take away 3. Now this works the opposite way. Okay, so what will happen on this this situation here is that the x take 2 all squared graph will actually move 2 units to the right. Okay, now how is that possible? Well, let's just plot the points and just see what happens when the function tells us that this is the relationship. Okay, so let's get rid of the table. Let's go y equals x squared. So let's just graph y equals x squared. And now I'm going to graph y equals x take 2 all squared. All right, let's check that one out. And again, you'll note that that's the same shape, but moved 2 units to the right. Okay. So it's a little counterintuitive because take 2, you'd think, oh, that you move all of the x values by a factor of 2. But let's find out why this kind of occurs. Right, so we've got -2, and we're going to remove 2 from -2, which is -4, and then square it. Okay, so that one there should be 16. Let's just see what the table of values says. Okay, so we've got -2, 16. Then it's 9, 4, 1, 0, 1, and what's the 4 going to be? 4 take 2 is equal to 2, 2 squared is equal to 4. So you can see the symmetry comes in there. Okay, so this one here would have to be 9. Would it be 5, 9? All right, let's plot those and just see what happens. So the first one is the x-intercept. Let's go 2 and 0. Next is 2, y 0, 1, 1, and 3, 1. Okay, 0, 4, and 4, 4. Let's go -2, 16 up there. Okay, so remember the graph should be symmetrical about this thing we call the axis of symmetry. Mine's not fantastically symmetrical. That really wouldn't match up well with that one there. But we can see same shape, but moved 2 units to the right. So this is y equals x take 2 all squared. All right, so see if you can work out what's going to happen with this one here. If this one moved 2 units to the right, I hope you will guess that this one moves 2 units to the left. Let's just try it and see. So get rid of the table, and we've got x plus 1 all squared. Let's have a look, and there it is. So blue has moved 1 unit to the left. Let's go to the table, grab those green values. So let's just change our table so that we get them. We want from -5 to 1. Okay, so we've got -5 is 49. Don't know how we're going to pop that on the Cartesian plane. 36, 25, 16, 9, 4, and 1. Okay, let's plot the ones we can. So when x is 0, we've got an x-intercept here? We don't. Something wrong here. -5. Right. All right, your rocket scientist teacher has just copied down the wrong table of values here. All right, so let's just undo that and note that -5, it's the green graph, Mr. Miller, green graph. 16, 9, 4, 1, 0, 1, and what's that last one? That's going to be 4, yeah. Okay, this should work a bit better. All right, like -5 is over here, and 16. -4 and 9, -3 and 4, -2 and 1, 0 and -1 and 0, 0, 1, and 1, 4. Okay, here we go. I'll try that again. Okay, so that is y equals x plus 1 all squared. Okay, so again, noting that it's that blue graph, all moved 1 unit to the left. So what effect does the h value have on the position of the parabola? Okay, so it will translate the graph h units to the left or right. It all depends on the value of h. How have the coordinate points changed compared to y equals x squared? Well, what's happened is that the y values, notice here that the y values are the same. So it produces the same y values for different x values. Okay, and the x vals have changed by h units. Okay, in this case here, they've gone up by h units. Okay, so instead of what would be 14, it's gone to 16. What would be, what would it be? Yeah, they've just gone up, either up or down by h units, these x values. Okay, but the y values have stayed consistent. All right, and so over to you. Okay, so this is an attempt to put it all together. Okay, so what I'm going to ask you to do is to work through this document here, use your calculator for it, and what we're trying to do is pick all of the different transformations that can be done and see if we can complete this table. All right, so pause the video here and then unpause it as you work through this to check whether you are right. Okay, so you've unpaused it now. Let's just quickly move through the answers to this. So we've got a basic curve y equals x squared. What's the value of a? A is the coefficient for x squared, that's 1. We're going to conclude that there's no reflection, no dilation, no translation, up, left or right, no translation up or down. It has a turning point, and that turning point is just that where the parabola starts to sort of goes in and then turns back on itself. We say that that's at 0, 0 for this one. The axis of symmetry is an equation. It's a straight line that runs down the center. So it basically says it's symmetrical about this line here. Okay, so 0, 0. The y-intercept is 0, 0. The x-intercepts are 0, 0. And if I had an original point -2, 4 on the graph, what would it become after transformations? Well, basically it'd be the same because this does not have any transformations. This is the most basic parabola. Okay, so -2, 4 will stay at -2, 4. Okay, and just note that if I slam -2 into this, -2 squared is equal to 4. So -2, 4 will become -2, 4 after no transformations. All right, let's have a look at this one. Y equals x squared plus 4. Our a value is the coefficient of the squared term, that's 1. So we're going to conclude that this is no dilation. Sorry, no, that's no dilation goes here. Now remember, if this a value is negative, then it's been reflected. Okay, there's no negative there, so no reflection. All right, has it been moved left or right? So what I do is I look for x plus something all squared or x minus something all squared. It's just x squared, okay? So there's no translation here. But this plus 4 is plus k, okay? And what this will do is grab the parabola and move it 4 units up. If the turning point originally is 0, 0, that point will move 4 units up as well. So it'll be 0, 4 will be its new turning point. The axis of symmetry, because it doesn't move left or right, will have an axis of symmetry at x equals 0. The y-intercept, okay, well the original y-intercept was at 0, 0, the origin, and it moves up. So it's going to be 0, 4. Doesn't have any x-intercepts because if that's my original parabola, y equals x squared, this one goes up 4 units, can't have any x-intercepts. All right, so what we do is to map a point, we go negative 2, 4 is the original point, and after the transformation, and what are we doing? We're raising all of the y values by a factor of 4, okay? So what negative 2, 4 will become is negative 2, negative 2, not 6, 8. All right, so that y value has jumped by 4. Okay, and we can try it out. If you put negative 2 into it, it's negative 2 squared is 4. 4 plus 4 is equal to 8. All right, let's keep rolling. Okay, so our a value on this one here. So it's got a 1 out the front of the thing being squared, so we're going to say it's an a value of 1. That means no reflection because it's positive, and because it's 1, it means no dilation. Now this one here has gone 2 units to the left. How do I know? It's plus 2 there. Remember that whatever that is there, it will shift it left or right by a factor of k. If it's plus 2, it'll shift it 2 units to the left. If it's minus 2, it'll shift it 2 units to the right. It's a bit counterintuitive, okay, but review that previous part there to see why. Now, this negative 1 will shift it 1 unit down. What that will do is also shift the turning point, okay? So the turning point is going to be picked up and moved as well. So the turning point, instead of being 0, 0, will go 2 units to the left and 1 unit down. So 2 units to the left will leave me at negative 2, and 1 unit down will be negative 1. That will also move the axis of symmetry, which would typically be at x is equal to 0. It's going to also move the axis of symmetry 2 units to the left. X is equal to negative 2. What's the y-intercept going to be? Well, the y-intercept is originally at 0, 0, okay? Now, what we can do to get the y-intercept is simply let x is equal to 0. So we've got 0, which is 2. 2 squared is 4. It's going to be 3. So when x is equal to 0, y is equal to 3. The x-intercepts. Okay, so this one here, to do the x-intercepts, that occurs when y is equal to 0. Okay, so we're going to say 0 equals x plus 2 all squared, take 1. 1 equals x plus 2 all squared. We're going to square root both sides, which will give us x plus 2 equals plus or minus 1. So when we root both sides like so, we do get that plus or minus. And the square root of 1 is just 1. Then we're going to remove 2 from each of these solutions, and we're going to get x is equal to negative 3 and x is equal to negative 1. Okay, so we've got 2 x-intercepts, one at negative 3, 0, and the other one at negative 1, 0. All right, the point negative 2, 4 is going to move 2 units to the left. So that will be, so negative 2, 4 is our original. That moves 2 units to the left, which will be negative 4, and 1 unit down will be 3. Okay, we can try that out. You slam negative 4 into there. Negative 4 plus 2 is negative 2. Negative 2 squared is 4. 4 take 1 is equal to 3. Okay. All right, let's have a look at this one. Our a value this time is negative 1. What does that mean? It means that this negative sign here will reflect it in the x-axis. There's still no dilation. All right, what we've got is 2 right, that's the translation, 2 units to the right, and 1 unit down. Okay, the turning point. What's the turning point going to be? So that is going to be, it was originally 0, 0. That moves 2 units to the right, it'd be 2, down 1, negative 1. The axis of symmetry moves 2 units to the right as well, that's going to be at 2. The y-intercept occurs when x is equal to 0. Negative 2 squared is 4. 4 negated is negative 4. Negative 4 take 1, negative 5. When x is 0, y is negative 5. The x-intercepts. This is an interesting one here. So there's our original parabola. It gets reflected, moves 2 units to the right and 1 unit down. Our parabola is going to be there. It doesn't have any x-intercepts. Feel free to graph it and check it out. In fact, let's do it. I moved the wrong way. 2 to the right. Okay, still has no x-intercepts, just moved the wrong direction. Okay, let's try this one out here. All right, so we're going to do this one on the calculator. So our A value is 2, no reflection because it's positive, dilation by a factor of 2 from the x-axis. All right, what's the horizontal translation? 1 unit right and 3 units up. All right, turning point. We'll change the turning point by translation. So 1 unit right will be 1, 3 units up will be 3. Moves the axis of symmetry 1 unit to the right as well. The y-intercept when x is equal to 0, 0, negative 1 squared is 1, 1 times 2 is 2, that's going to be 0, 5. Okay, x-intercepts. Okay, so originally it was that. Gets dilated, moved 1 unit to the right and 3 units up. It won't have any x-intercepts. All right, map the point. Okay, so now we didn't do that for the previous one. I'll do this one and then I'll knock over the previous one. Right, so we started with -2, 4, and then what we're going to do is dilate it by a factor of 2. Now, dilations from the x-axis change the y value. So this becomes -2, 8 after the dilation by a factor of 2. Then we translate 1 unit to the right, we'll move that x value to -1, 8, and then let's translate it 3 units up, -1, 11. Right, let's just try it out. When I stick -1 in here, that's -2. -2 squared is 4, 4 twos are 8, 8 plus 3 is 11. All right, let's try the previous one. So we started with -2, 4, which ends up being after the reflection. So reflections in the x-axis change the y value, so it's -2, -4. Then we're going to move it 2 units to the right, 0, -4, and then up 3, 0, -1. Again, you can try that out. That's actually the y-intercept, I think. When x is 0, y is -1. All right, let's try this last one here. It's got the whole kit and caboodle. Okay, so our A value here is -1/4. All right, so it's got a reflection in x-axis. It's got a dilation factor order from the x-axis. It goes 2 units to the right and 2 units down. So what's our turning point going to be? So the dilations and the reflections don't actually affect the turning point, right? So the original 0, 0 turning point will move 2 units to the right and 2 units down. So that's going to be 2, -2. Right, our axis of symmetry will move 2 units to the right, so that's x is equal to 2. Y-intercept when x is equal to 0. Let's see if we can get this one out. 0, -2. -2 squared is 4. 4 multiplied by a quarter is 1. 1 negated is -1. -1 take 2 is -3. When x is 0, y is -3. All right. 2. So this is not going to have any x-intercepts as well. I encourage you to graph it just to check it out. And let's map the point. So -2, 4 will become, after the reflection in the x-axis, so reflections in x change the y values. So that's going to be -2, -4. Then that's going to be -2, and we multiply by this factor here. So it's going to be dilation factor a quarter from x. That changes the y value. So it's going to be -2, -1. And then it goes 2 to the right, 0, -1. And then finally, it goes 2 units down, 0, -3. Okay, which is also the same as the y-intercept. So not easy, and for each equation, have a look at the table of values, sketch the graphs on the calculator and use your graphing calculator to support you as much as possible doing this. That's okay at this stage.